Hey everyone, my name is Scott Pecorello, and welcome back to another episode of Beyond the Forecast. Today I am joined by Jared Goldberg, who is our head of data science, and also Joshua Feldman, who's our head of meteorology. And today we have a very special episode because we're announcing a new product called SevereCast. SevereCast is our threats in motion severe thunderstorm prediction model, sort of a first of its kind product that produces these rolling, continuous updating hazard polygons that move alongside a storm and update in near real time with new data. So very excited to dive into that today, tell you what it is, how it works, different use cases that we are finding our customers leveraging it for today. So I guess to kick things off, Jared, maybe I'll pass it over to you just to start talking through high level, from a data science perspective, what SevereCast is and what it does. And then Josh would love to hear, your input as well from the meteorological standpoint. But yeah, Jared, if you want to kick us off.
Yeah, I think some of the challenges with severe weather are that it's really difficult from a hyperlocal perspective to know exactly when and where, a convective system, the actual severe issues are going to be happening. Obviously, people are used to looking at radars and you can kind of see those pockets of those stronger colors in the middle, but a lot of times the granularity isn't great. You also are not really sure, hey, is there hail going on in there? Or is it really just kind of wind and rain? Is there really serious impacts going on? And obviously for tornadoes, obviously this is relevant as well. So I think the big strength of SevereCast is along with our other weather optics products, we're really trying to simplify decisions around these convective events for our clients. So instead of being like, hey, here's the radar, take a guess. Maybe there's this huge hail area that the National Weather Service says, well, somewhere in here, there's a general, hail warning, or we think hail might happen somewhere here. We're talking about a very hyper local. We're giving you the probabilities within certain very specific polygons that update very quickly, where we think, how high the probabilities of hail, of wind damage, of other aspects are. So it's about two things. It's about the hyper locality. We're taking sort of the big picture and we're baking it down to these are the areas where we think serious impacts are going to occur. There's also a forecast component. So we do forecast it in the movement of those systems into the future. And just like other products, we're trying to make it easy for you to use as well. So we're going to be integrating it into our alerting suite, integrating into other ways where you can actually take preventative action based on these things. And yeah, in terms of the modeling itself, obviously some really exciting technology that we've been working on from a machine learning and an AI context around these things. So we're talking about making predictions, probabilistic predictions using AI about what's your probability of significant hail falling within that polygon? What's your probability of severe winds happening? And so, yeah, just really excited to roll this out and yeah, looking forward to the value and the use cases that our clients are going to get out of this because we understand that things like hail and high wind from these localized systems are really hard to predict, and we're here to make those decisions easier and hopefully protect assets in the line of fire.
Yeah, absolutely. I think that's a great point about, everything we do at Weather Optics is translating, right, weather data into how it's going to impact you. And so SevereCast is no different, right? Breaking down exactly what threats are going to happen within a given thunderstorm cell and doing that at a super hyper local level. So Josh, from a weather and meteorological standpoint, can you tell us a little bit more about how SevereCast works and why it's different than what maybe exists on the market today?
Yeah, absolutely. Just to give you some context, thunderstorms are exceptionally difficult to forecast. They remain a challenge in meteorology because they're just so chaotic. Sea breeze comes in a little too far east one way, a little bit too far and the other way. You got two different places where thunderstorms can form, and they're short-term processes. They happen over a time scale that weather models can't really predict. And so all this is to say that while we can predict where in a broad area where thunderstorms are going to form, and maybe what risk those thunderstorms could have within a few days, within a few hours is really the time scale that it takes until we can really get a good understanding of, yes, thunderstorms are going to happen. But even then, Scott, we can't really say where the thunderstorms are going to happen. Imagine a huge pot of kernels, popcorn kernels hanging over a fire, right? You know that if the fire is very hot, that popcorn is going to pop, but you don't know where in the pot the first kernel is going to pop, and you don't know which one is going to be first. That's really what we're looking at here. And so With severe casts, we can look at those individual popcorn kernels. We're looking at individual cells inside the thunderstorms every 2 minutes. And based on new satellite and radar data, we update the risk of that thunderstorm producing severe weather. And we break it down by hazard. We break it down by hail, wind, tornado. We can tell you where it's going. And then, if you were to think about baseball, what the Storm Prediction Center can do and what the National Weather Service does with their alerts is they say this inning, a batter is going to hit. We don't know where it's going to hit. We just think it's in the field. Oh, obviously it's going to be in the field. But what we're doing is we're basically saying we think batter number 2 is going to hit. It's going to be a single line drive down right field is essentially what we can do. And we get a new forecast every 2 minutes, which also adds another additional feature that you can't get from just a weather service warning. Those are 15 minutes at best. You get new information. But for us, with SevereCast, you can track a storm every 2 minutes throughout a cycle before you get a warning. And so you can identify the risk that a thunderstorm could impact your assets before a warning happens.
I think something else that is really exciting that SevereCast does, Josh, is that it kind of takes this concept that's been talked about and used a bit more as maybe a buzz phrase, but threats in motion, right? Being able to track a thunderstorm once it develops and then as it's moving along. As we know, the National Weather Service does a great job of creating, human input, these kind of manual polygons, right? Where a severe thunderstorm warning is, where a tornado warning is. But it's kind of rigid in the fact that it might take up half a county or a whole county, and it might be updated, to your point, every 15 minutes, right? As that storm moves along. When in reality, storms are constantly moving. The atmosphere is fluid, right? The storms are moving at all times. They're developing and changing in real time. And so SevereCast having this, 60 to 120 second update cadence and being able to constantly change and basically show what the risk is of any given thunderstorm cell and where it's going to go out for the next 60 minutes, that is something that we're considering to be like this threats in motion forecast where we're constantly following that storm as it develops. Can you talk a little bit more just about, that concept and why it's important to have that, in addition to or over to maybe some of like the more rigid polygon watches and warnings and advisories that are issued today?
Absolutely. So with threats in motion, like if the Weather Service sends you an alert, that alert could be valid for 30 minutes over a huge area, like you said. But you don't have any idea of what that thunderstorm is doing, where it is. Going back to the baseball analogy, the baseball could be the track of severe weather, and the air time is how long is it severe. You don't get any of that information when you're just looking at the polygon. But if you're able to track every 2 minutes, you're basically seeing where the ball is going, and you can see the risks too. So like hail, tornado, wind, you can see in real time how those risks, individual risks, are changing. Is this a high chance of there being a tornado? Is the risk increasing? What about the risks of wind and hail? And thunderstorms are chaotic, which means they're dynamic. They change a lot, which means that during certain thresholds in the storm's lifetime, you can see with SevereCast what those certain hazards might be and how likely that's going to impact you.
100%. And we're looking at a real example here. This is in Florida near Tallahassee. Our SevereCast is picked up on a severe thunderstorm here. Want to briefly walk us through maybe some of what we're seeing, obviously the different types of risks, and then being able to identify, what areas are in the path. But it looks like for this specific cell, we're looking at tornado versus hail versus wind risk. And we can compare that to some of the other data we have as well.
Yeah, so this is a severe thunderstorm, or possibly this is a strong thunderstorm. I actually don't know that it's warned. We can actually turn on the government alerts layer. And in fact, it is both severe warned and it's tornado warned. Scott, I'm curious of what this particular SevereCast forecast was 10 minutes ago versus right now. But basically what we're showing is this warned storm for both severe thunderstorm and tornado has a moderate risk of producing wind and a low risk of producing a tornado. Now, I'd argue that any risk of a tornado is something to be concerned about. But now that we just saw in real time, the risk went from low to medium. One could probably conclude that maybe this storm is lowering in threat level, that maybe I don't need to consider the severe thunderstorm warning as it's approaching me to be as intense anymore. And conversely, if this were to be increasing, you would have a greater confidence that where I am inside these 4 polygons in the next hour could impact me severely. Um, and one interesting thing I want to point out, guys, if you turn on the radar layer, you should be able to see that the SevereCast polygon, at least now, in real time, captures the shape of a cell, right? Like a user just looking at the portal, just looking at radar reflectivity cannot gauge what the particular hazards of that cell is. I mean, I see orange, I see heavy rain, but I don't see anything else that communicates risk. Whereas SevereCast takes that orange blob, within this orange blob moving in this direction, there's a moderate risk of severe weather. It's moving southeast at 28 miles per hour. Check in 2 minutes, and we'll give you another update on how that risk has progressed.
Yep, exactly. And even beyond, I agree. It's great for translating the radar, right? To your point, there's all these different colors that a user might be looking at on the radar, but not know exactly what it means. And SevereCast is great at translating, what the actual threat is. I also thought it was interesting when we went back to the National Weather Service, watches and warnings here. Obviously, we have the tornado warning here, and we have the severe thunderstorm warning as well. But you'll notice that SevereCast is identified in kind of like a smaller, more defined region. And it's also ahead of where that tornado warning and the severe thunderstorm warning is. So because it's updating more frequently and, taking into account the real-time scans, oftentimes I think we see that it's ahead of some of these warnings and advisories. And I think this is a good, case here
Absolutely.
where the actual threat you can see is, out in front of what's existing potentially from the National Weather Service.
Well, not only is it ahead, it's also the shape of the actual storm.
And we can also see here that this warning, it
Yeah.
looks like, uh, says no longer capable of producing a tornado. So I think this is also another good example, right, where there appears to be a tornado warning issued, but it doesn't seem to be valid anymore, producing a threat. And so while that remains active and might be alerting users of a tornado, SevereCast has promptly picked up that the risk is actually minimal. So I think this is a great example of the advantages of using this in tandem and sometimes potentially instead of some of these warnings from the National Weather Service as well.
One final
Jared,
thing
I'll turn it over to you. Oh, sorry. Go ahead, Josh.
you can add, that as you're highlighting over this, you still get alerts for your assets inside those polygons. So that if you do have an asset in those polygons, you can have higher confidence that because we get these granular insights every 2 minutes, that you will be impacted or not impacted in some fashion.
Absolutely. Jared, I want to see if you had anything to add about just the situation we're seeing here and some of the advantages that SevereCast clearly poses as we launch this new product. And you can see just now, as I was on screen, it's actually changed to a low threat. So we're continuing to see this cell die out while we're seeing active warnings from the National Weather Service showing, tornado risk and severe thunderstorm risk.
Yeah, no, I think this is really good, right? I think it shows a lot of the advantages of some of this more advanced data versus some of the National Weather Service warnings. I think this is a really good example to call out. Like there are differences between sometimes what our models are outputting for risk versus what these National Weather Service polygons are saying. And I think it's a great use case of like, for folks that really want to get the signal from the noise, right? Like it's important to be using some of these more advanced products as opposed to just relying on National Weather Service, despite, obviously the National Weather Service doing really good work for manually sort of alerting on a lot of these things. I think the last point I wanted to make was, related around those differences in risk levels. So another thing at Weather Optics that we're aware of is when it comes to alerting folks for this data, we also want to be conscious of the fact that let's say we alerted you for a severe polygon, and then it went from minimal to low, right? Or went from high to medium or something. We want to make sure not to overwhelm with alerts as well. So we're also working on the back end on our end to make sure that we're not inundating folks with alerts. If their threat levels goes down, make sure not to necessarily re-alert them. However, right on the flip side would be, well, if we see you're approaching a severe a severe polygon and your threat and the severe polygon went from medium to high, right, or went from low to medium, those could be events where we believe it's worthy of alerting. So, yeah, another aspect that we're working on is, yeah, just making sure that folks are properly alerted to things that they should be aware of while not being over alerted and inundated with noise when it comes to these sorts of events.
Yeah, I think you're touching on something that's super important, which is like, what are the actual use cases then of this data? And one of the things that we hear most often is how drivers, for example, feel very over alerted when they're on the road. So trucks driving are constantly inundated with, a flood warning or severe thunderstorm warning or a high wind warning. And that becomes noise, right? Eventually, these drivers may choose to ignore that because they're getting these severe thunderstorm warnings so often. And in a lot of cases, maybe the conditions don't meet that criteria because it's such a large polygon. And obviously, you want to be rather, safe than sorry. But they're getting over alerted by this information. I think another huge advantage that you just pointed out of SevereCast is the ability to not over alert. So, unless the threat is getting worse, we're not going to necessarily alert you again. And we have some kind of cooldown logic that helps with that. So I think that's a huge component of why would a trucking company or logistics company or really any organization want to adopt SevereCast over what's already existing out there from the National Weather Service or from radar. And that alerting piece is really key. Cutting out the noise, telling the driver, the user exactly what they need to know is so critical and a big part of why we created this product, right? And not only that, but like specifically what they need to know, right? So rather than severe thunderstorm warning, blanket, right? It's like, no, actually the issue here is that there's wind gusts that are going to be 30, no hail, no tornado, right? So getting into the details plus not having that noise over alerting. I also just noticed this, new polygon pop up. This is another really great example of, I think, what we're talking about, right? Where we have a special weather statement from the National Weather Service, and you could see the amount of area that this covers, right? It's a huge region, and we have our SevereCast polygon, which is pointing out that there's only a certain part of this region, really just the middle section, where we believe that there's going to be a higher risk. So again, a driver that maybe is, going I don't know, further west on this particular route, maybe they don't need this, but they get this noise anyways. And so it just becomes repetitive. SevereCast is clearly cutting down where that actual area is. So I think this is another really good example of how this data could be used as an advantage for sure. Other use cases that we can think of here, I mean, trucking is the big one, right? Being able to intersect where that driver is going because we are able to connect with the telematics, the routing guidance, and we're able to say, hey, you're entering a certain severe weather polygon. I'm thinking of other, outdoor safety use cases when it comes to utilities, when it comes to general facilities where there could be people that are working outdoors and there's human safety involved. Eric, could you talk us through maybe some of the advantages that you can get using SevereCast from just an outdoor safety perspective beyond just trucking?
Yeah, I mean, there's a lot of use cases, right? So another one that comes to mind, right? Let's put ourselves in sort of a static context, right? Let's say I'm someone that has distribution centers or just individual static locations with different assets, or as you were sort of pointing out, human assets, right? Like people that are doing work outside, folks that are spending time outside for whatever reason. There's still a lot of value here, right? Like, and we understand that specifically, I want to talk about hail, right? Hail it's very quick to develop, right? We get these large swaths that say, hey, today's, or at least, out in Colorado, they say, hey, today's a high weather outlook, and they paint the entire city and say, maybe there's a chance of hail. But again, if I'm someone, let's say, even like a car dealership that has their cars outside, right? That needs to know, well, we understand that there's a chance that, some of our inventory may be affected by this, but I don't want to necessarily have all my folks moving my assets, inside unless there's a serious chance that the hail's actually going to pinpoint my specific location. So I think also that sort of the forecast piece of SevereCast is also super important, right? Like we're showing not only where the threat is now, but at least, a level of heads up of like in the future, this is where it's moving. This is where we think the severe threat may manifest in the future. And that may give folks that have folks outside or that have assets outside, like, hey, there's a difference between today, something might happen somewhere, almost like that popcorn analogy, versus this is where it's happening now. This is where we think it's moving. And this is another case where when we have a severe polygon that has a risk of hail and you are in the line of fire in terms of these future polygons, that's probably when it's really time to take action. So the first piece, you can look at I guess alerts beforehand or the weather optics sort of impact index suite to say before your day arrives, like, is there chances of severe weather that may take place on this day? And if we're within that day and we're within the, okay, it's go time. We need to start monitoring these storms, making sure our assets aren't at risk. That's where, okay, if you're in the line of fire of a polygon, maybe that's your threshold to take action, right? So again, it ties back to how's the weather optics data helping folks? Like, it's helping you take action when you really need to. And kind of like we've shown, if you have a severe polygon that's scheduled to move over you and there's at least, a moderate risk of hail, or, enough hail that you think could damage either your people, your assets at a static location, you can set up alerts for those static locations. You can monitor the portal for those static locations. But yeah, we want to make it easier for you to say, do I need to take action? Do I care about what's happening versus, maybe there's a chance
100%. And something else that I just, thought of was looking at the National Weather Service warning, versus the simplicity of what SevereCast shows, right? Having this read out loud to, let's say, a driver, that's in a vehicle, understanding, the specific hazards, radar indicated, hail damage to vehicle. This is all great information, but one of the other advantages of SevereCast is the conciseness of the data, right? So just showing you hail risk, wind risk, tornado risk, right? Minimal, quarter size hail, winds up to 40, right? Very concise, easy to use information. That just makes everything super simple. And again, that's a core part of weather optics and kind of how we operate and what we believe in. The last thing I want to touch on when we have time here is just talking about how this is integrated into all of the weather optics products and deliverables, right? So as we launch new products, we like to make sure that they are included in every aspect of what we offer here at Weather Optics. So I think one thing that's important to touch on is setting this up for driver alerts. That's a big one. So now in the platform, a user can come in and set up SevereCast alerts that say, anytime a driver is at risk of a, moderate severe cast threat or a certain type of weather parameter, we can alert that driver specifically using this product that updates every 60 to 120 seconds, right? Reduce the noise, allow drivers to truly understand what severe weather risks exist ahead of time. We can do the same thing at a location-based level. So if you have key facilities, warehouses, outdoor sites like construction, or Jared, to your point, car dealerships, anything that might be fragile property, you could also set up location-based alerts. So set those same thresholds and risks and parameters and get severe cast alerts that way. Lastly, everything that we offer here is available via API. So being able to pull this in directly into the environment that you live in is also an offering that we have. And of course, being able to just access it directly in the platform when there is a severe weather outbreak, when there's any sort of issue happening, being able to see this visibility directly here in the system, I think is super important as a back-end dispatcher, manager, or whatever your job might be monitoring to make sure that severe weather is not impacting or causing harm to your operations. We are almost out of time here. Last thoughts, anything to add at the end of the podcast here? Josh, I'll start with you, and then Jared, I'll snake around to you and we'll wrap up.
Just that this is, I think, such a great tool for public safety and for making sure that if you have something that needs protected, people, assets, this tool can give you greater confidence in achieving that.
Absolutely. Jared?
Yeah, I think predicting legitimate weather risks, uh, there's a lot of different ways to go about it. And I think of it as almost like a puzzle. And one of the most difficult puzzle pieces to make sure someone, client assets are fully protected are these really short-term pop-up thunderstorms that can have these severe risks. And unfortunately, they're one of the most difficult things to account for. But we think SevereCast is a really important piece of the puzzle here to make sure to get you covered for, hey, in a couple days, are there going to be large scale impacts to my operations? Let's maybe adjust. And then also, hey, in the more short term context, because as we know, thunderstorms are actually one of the most difficult things to forecast at that larger forecast interval. We want to make sure we have folks covered at every step of the way. And so just really excited for SevereCast for our clients to see how they use it, to see the value it adds, and yeah, to save some folks from losing assets and yeah, saving their folks, people as well. So
Absolutely. Well, we're excited to roll out SevereCast. It is available today. So, excited for this product to get into the hands of the users that can really take advantage of this sort of data. Jared, Josh, thank you for joining me for another episode of Beyond the Forecast.
Of course.